Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to take a look at another electronic quiz. Here it's our circuit. This is the ideal op-amp and this is BJT transistors, and we're looking for the values for VB and IL. But before we get started, if you're new here, please give me a thumbs up, hit that subscribe button and also the notification bell, so whenever I upload a new video you'll be aware of it. Let's jump into it. This is our question. In this circuit, the op-amp is ideal. What is the meaning of the op-amp is ideal? Which means that the current through this op-amp, through input port of this op-amp is 0, and also the voltage in the positive port of this op-amp and the negative one are equals, which means that if this voltage is 4 volt, so this node in here then again is going to be 4 volt for this node. Now we're looking for the values for VB and IL. So here, and the wave base emitter on is 0.7 volt and alpha is approximately 1. Well, what is the meaning of this? This means that for this BJT transistor, the collector current and the emitter current is almost identical, okay? Which means that we're going to neglect the base current. And in other words, you can say this beta is really higher than 1. Because the real relationship between I collector and IE is this one. IC equals to alpha times IE. And if alpha is approximately 1, so I collector and emitter current are equal. So here now how we can deal with this problem. Here, first of all, for this IL, you can see that this is here is 4 volt and this is 0.5 kilo ohm. So we can simply calculate this current. This current is equal to the voltage, which is 4, divided by the resistor, which is 0.5 kilo ohm. So this is equals to 8 milliamp. So here 8 milliamp through this resistor, and here you have 2 milliamp from this node. So by using a KCL in this node, let's call this node maybe node X, okay? Node X for here. So using a KCL at node X, you can simply calculate IL actually, because here IL is going through this node. So IL plus this 2 milliamp which is going through this node and is equals to this 8 milliamp which is going out of this node. So by using simple mathematics, you can see that IL is equal to 6 milliamp. Okay, here this is our first unknown value. And now how about VB? VB, for calculate VB you can use KVL. You see here in this path, you can see it in this path. What is VB? VB is equal to the voltage drop through RL, which is RL times IL, plus this voltage node in here, 4 volt in here. Okay, now we already calculate IL. So an RL equals to 0.5 kilo ohm times this 6 milliamp for IL plus 4 volt. So here this kilo and milli are crossed out, so we have left with 0.5 times 6, which is 3 volt plus 4 volt. But I already forgot one thing. Be careful about that. This is a base emitter voltage of this transistor. So whenever you want to calculate VB, you have to take care of this as well. So let me just again VB is equal to V based emitter on for the transistor, then RLIL plus 4 volt. So which is this one is 0.7 volt plus for this one in here 0.5 kilo ohm times 6 milliamps. So here we have this one in here. For the final value you can have 0.7 plus 3 and plus 4, which is equal to 7.7 volt for VB. So option C is the right answer for VB and IL. As you can see, I try to use the circuit picture and put some information on that. And considering the op amp is ideal, I start with that one. This input node equals to this V minus node, and then I calculate the current through this resistor, then using KCL to calculate IL, and then using a KVL to calculate VB. Here it is, our problem solved. So if you guys have any questions relating to this problem, please let me know in the comment section, and thanks for watching. I will see you in the next video.